Today we are going to be talking about Chapter 17, which is electrochemistry. First, I'm going to talk about galvanic or voltaic cells. Now, first off, they are spontaneous and also known as redox reactions. Looking at an image, there's two different metals that are connected by a salt bridge. The two metals are either going to be copper or zinc, and each side consists of two half cells. So like I said, zinc and copper will make up the two metals. Within the solution, there is a dissolved salt and the barrier that allows ions to diffuse through. We're going to look at the overall equation that helps describe this reaction. To break down this equation, we're going to first circle our two zincs and then square our two coppers. On the left side is going to be the zinc, where we displayed it right here. In order to balance out the charges, we're going to have to add 2 electrons to this side, and the same goes to this in order to balance out the charges. This is going to be the oxidation reaction, and this is going to be the reduction.
A galvanic cell, or voltaic cell, named after Luigi Galvani or Alessandro Volta respectively, is an electrochemical cell that derives electrical energy from a spontaneous redox reaction taking place within the cell. It generally consists of two different metals connected by a salt bridge or individual half cells separated by a porous membrane. Volta was the inventor of the voltaic pile, the first electric battery. In common usage, the word battery has come to include a single galvanic cell, but a battery properly consists of multiple cells.
Next, we're going to be talking about batteries. Batteries are perhaps the most important application of galvanic cells. This is because they are so compact and long-lasting. An example of a battery is a dry cell. Dry cells are called dry cells because the electrolyte is not a liquid, but instead more like a paste. The equation for the anode of a dry cell, an example for an equation of the anode of a dry cell is zinc plus 2OH yields zinc oxide plus H2O plus 2 electrons. And an example equation for the cathode is 2MnO2 plus H2O plus 2 electrons yields MnO3 plus 2OH.
So the next concept we're going to talk about is electrolysis. Basically, electrolysis is using an electric current to bring about chemical change. So in an example of electrolysis, we're going to talk about the electrolysis of molten sodium chloride. In the anode reaction, it loses electrons, and then in the cathode reaction, it gains electrons. And then in the overall reaction, it's basically the summation of the anode and the cathode reaction.
Vital to make a battery is this electrochemistry. You take two half cells and connect them up so well, with a load to power in between. You need to have electrodes, you see, full of that metallicity. Let electrons flow, across the salt bridge we go, allowing us to make electricity. We start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter the cathode, and reduce the cations, and the anions go through the salt bridge back to where? We start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter and reduce the cations, and the anions go through the salt bridge back to where?
Everybody now!
We start at the anode, electrons are lost there, and go through the wire, and through the load on fire. They enter the cathode, and reduce the cations, and the anions go through the salt bridge back to where? We start at the anode, electrons are lost there, and go through the wire, and through the load on fire. ions go through the salt bridge back to where?
Where?
We start at the anode, electrons are lost there.